Good day. So we have a question. The firm is placing 3 orders for supplies among 3 different distributors. Each order is randomly assigned to one of the distributors. A distributor can receive multiple orders. Find the probability that A, all go to a different distributor, B, all go to the same distributor, or C, exactly 2 of the orders go to one particular distributor. So before we tackle this exact question, instead of using orders and distributors, we can use the notion of dice. So each independent die has 6 possible sides. Right? This is true regardless of how many additional dice you add. Each one will individually have 6 possible sides. So if we correlate this back to question 19, it'll be easier to do question B first. Right? So if we're saying all 3 orders go to the same distributor, that's the same thing as saying each individual dice lands on the same number. Right? So if dice 1 lands on 1, that's a 1 in 6 chance. Correct? If dice 2 lands on 1, that's also a 1 in 6 chance. If dice 3 lands on 1, that's again a 1 in 6 chance. Right, so if we have all 3 scenarios occur at the same time, that's a 1 in 6, a 1 in 6, and a 1 in 6. So you times all 3 of them, which would equal 1 in 116. Okay. However, that's specifically if we have the number 1 used in all 3 scenarios. We could also have the scenario where it's 2 in each scenario. Could have it as 3 in each scenario, 4, 5, and 6, correct? So in that case, we times the final answer by 6, as we could have 6 different scenarios where we have each of the same number. The second scenario we could have is when all numbers are different. Right? So this would occur when, for instance, we could have the first dice equal 1 in 6, so we have a 1 in 6 chance of getting that. Then the second dice can be any other number other than 1, so it could be 2, 3, 4, 5, and 6. So that means there's a 5 in 6 chance of that occurring. Then the third die can be any number other than 1 and 6, or whichever point that could be. So it can't be 1, it can't be 6, so it could be 2, 3, 4, and 5. So that gives us a 4 in 6 chance of occurring. Just like as in the first one, we times them all together. So this would give us a 5 out of 54 of occurring. And as in the different ones, or sorry, the same ones, there are 6 possible different scenarios that may occur. Right, then we have the third scenario where it is exactly 2 orders go to one particular distributor, which means that the third one would go to any other one. Right? In the case of the dice, that would mean that the first dice could be a 1, and the second one would also be a 1 to be the same number, and then the third one would be any other option, so it could be 2. Right? So that means it would be 1 out of 6 times 1 out of 6 times 5 out of 6. And just like the previous examples, that could also go in 6 different scenarios. Now that we have established the principles with the dice, we can actually proceed to answer the questions at hand. Alright, so for question A, it says find the probability all orders go to different distributors. Right, so we have 3 orders, we have 5 distributors. Let's call arbitrarily distributor A, distributor B, distributor C, distributor D, and distributor E. Right? Each individual one has a 1 in 5 chance of receiving an order. Okay? So if we were to begin and say, well, let's say distributor A was the first distributor to get an order, that's a 1 in 5 chance that A is the first one to receive it. Right? Now we want something different. So in the next case, it could be B, C, D, or E, which can receive the orders for it to be different. That's 4 over 5. And for the last one, for it to be different, let's say A and B were the first two to receive their orders, it would remain C, D, and E as the possible candidates for different ones. That's 3 over 5. Okay. Although this may seem at first as the entirety of the answer, it is entirely possible that the first order might not be A, it could be B, it could be C, it could be D, and it could be E. That means we have to times it by 5 for it to be completely different throughout the rest. If we were to utilize permutations and combinations to do this, we would use permutation. And the idea that probability, all of them go to a different distributor, all options. This means you can incorporate it also going to the same one, and thus we allowed repetition. Right, so we can say 5, because the 5 distributors, 5 different locations, it could go to P3 because you want 3 different ones over 5 to the power of 3. We can apply this also to the next question for B, which after understanding the concept should be considerably easier, because for instance it could go all to A, so that just means 1 over 5 times 1 over 5 times 1 over 5 times 5, because you could be A, B, C, D, or E. This is the same as 5p1 over 5, so 3. And then of course we have the third option, which is in a way the combination of the two. So we could have distributor A, and then distributor B, or any other option, C, E, or D, on my alphabet. That could be 1 over 5 times 1 over 5 times 4 over 5 times 5. That would give us that would give us 0.16, sorry. This would be the equivalence of 5p1 times 4p1 over 5 to the 3. I should have written that, sorry. So 5p1 times 4p1 over 5 to the 3.